Hello, this is video 6.2, one-step equations with rational coefficients. Okay, today we are going to learn I can solve one-step addition and subtraction equations, and I can solve one-step multiplication and division equations. This is from EE4, use variables to represent quantities in a real world or mathematical problem, and construct simple equations and inequalities to solve problems by reasoning about the quantities. So I'm going to minimize myself. Let's begin. Solving one-step equations. A coefficient is a number in front of a variable that is multiplied by the variable. So for example, we talked about this a little in our last lesson. 4a means 4 times a. 3x means 3 times the number x, whatever gets put in there for the letter. 16 times b, 2/3 times y, and -4/5 times p. That's a coefficient, the number in front of the letter, in front of the variable. A one-step equation requires one step to solve it using inverse operations. An inverse operation is the operation that is the opposite to the one currently being shown in the equation. The inverse operations undo each other. So they're the opposite. So if you're adding, you're going to subtract. If you're multiplying, you're going to divide. If you're dividing, you're going to multiply. If you're subtracting, you're going to add. Those are inverses. So subtraction is the inverse operation of addition. Addition is the inverse operation of subtraction. Division is the inverse operation of multiplication. And multiplication is the inverse operation of division. Let's see how to do this. So a one-step equation requires one step to solve it using inverse operations. So we have p plus 6 equals 24. So some number here plus 6 will get me to 24. Now I know you can probably do this one in your head, but I want to show you the steps, and these are going to become very important that you do the steps. So we have to use inverse operations. We're adding a 6. We have to subtract a 6. 6 is being added to p. So we have to do the opposite. We have to subtract 6. So we're going to subtract 6. Notice how subtracting 6 is going to get us to 0, right? But whatever you do to one side of the equals, you have to do to the other side. So we subtracted 6. So what do you think we have to do on this side? Subtract 6. So you must do the same thing to both sides. Okay, so we're going to subtract 6 from the other side as well. That keeps our equation balanced. Now we end up with p, that's still there, plus 6 minus 6 is 0 equals 18. So now the p plus 0, we can just drop the 0, right? Because any number plus 0 is just the number. So if this was a 2, for example, 2 plus 0 would just be the 2, right? If this was a 4, 4 plus 0 would just be the 4. So we can drop the 0. So that's what we're going to do. And we're going to get rid of the 0, and p is just going to equal 18. So if I was to plug 18 right here, I should get a true statement. 18 plus 6 should equal 24. So that's how you check your work. You can check it that you have the right answer by substituting the answer in for the variable in the original equation and checking that the statement is true. So I'm going to plug the 18 in for p, and I'm going to add 18 plus 6 is 24. So that is true. So we did it correctly. See another one. 16 plus x equals 47. 16 is being added with x, so do the opposite. Subtract 16. Whatever you do to one side of the equation on the equals, you have to do to the other side. So now we get 16 minus 16 is 0. The x is still there. And 47 minus 16 is 31. Get rid of the 0 because we don't need it. We're left with x equals 31. We check that by plugging the 31 back in for x and seeing if we get a true statement. Is 16 plus 31 47? True, it is. So we did it correctly. Okay, let's do another one. R minus 11 equals 40. Notice that 11 is being subtracted from R, so we do the opposite. We add 11. So we're going to add 11, but whatever we do to one side of the equals, we must do to the other side of the equals. So we're going to add 11 on that side. Notice how negative 11 and positive 11 will cancel each other out and become 0. So you'll be left with R minus 0 equals, that's the wrong number, 40 plus 11 is not 29. Let me fix that for a sec. Okay, I fixed it. So 11 has to be added to both sides. And then we get R minus 0 equals, now 40 plus 11 is 51. So that's better. So now we get rid of the 0, and we have R equals 51. Then we check. We plug 51 back in for R, and we get 51 minus 11. Does that equal 40? It does. So it's true. So we did it correctly. Okay, let's do the next one. Negative 4 minus S equals 18. S is being subtracted from negative 4, so do the opposite. You're going to add 4. This is negative 4, so you're going to add 4. So add 4 to both sides. So the negative 4 and the positive 4 will cancel each other out. And then 18 plus 4 is 22. Now we have to get rid of the 0. Now notice how we have a negative S. Okay, so we had to do one more step, so I had to fix that. So we have to divide by a negative 1 because we have a negative S here. So we divide both sides by the negative 1 because we have to do the same thing. And I don't think I fixed the next one. So got rid of the 0, and then we divide a negative by a negative, we get a positive. So it should be S equals, not R, it should be S equals, right here, negative 22, because if you divide positive 22 by negative 1, you get negative 22. So then we could check. Okay, so it's S equals negative 22. We just take the negative sign and move it to the other side, basically. Then we can check our work. If we plug in a negative 22, I hope that's a negative 22 that shows up. That's a positive 22, so we have to add a little sign there. Negative 22. So negative 4 minus a negative 22 is negative 4 plus 22, which equals 18. Okay, so the answer is true. Negative 4 plus 22 is 18. Positive 22, because it's two negatives, we'll make a positive. Okay, let's look at another one. X plus 3.2 equals negative 8.5. So 3.2 is being added to X, so you do the opposite, you subtract 3.2. Do it to both sides of the equals. And then you get 0 for the positive and negative value, and you have X plus 0 equals, and then you subtract negative 8.5 minus negative 3.2 is really negative 11.7. It's getting more negative. And you get rid of the 0. X is equal to negative 11.7. To check it, you plug it back in for X. Negative 11.7 plus 3.2 leaves you an answer of negative 8.5. So it's true. Let's look at another one. Negative 2/3 plus y equals 8. Y is being added to negative 2/3, so do the opposite, add 2/3. Add 2/3 to both sides. So then the 2/3 and the negative 2/3 cancels out, and you're left with y equals 8 and 2/3. Get rid of the 0, and there's y equals 8 and 2/3. Plug that back in for y. Negative 2/3 plus 8 and 2/3 should give you 8, and that is true. Okay, give some of these problems a try. See you back in a moment. Welcome back. Let's continue. Now we're doing multiplication and division equations. So we have 6 times t equals 24. 6 is being multiplied to t. So do the opposite, divide by 6. Whatever you do to one side, you must also do to the other side of the equals, so divide the other side by 6. Now we can use canceling to get the variable, the t, by itself. Cross off the 6's and you're left with just t. And then 24 divided by 6 is 4. So t equals 4, and we can check that by plugging in 4 for t and seeing what we get. 6 times 4 is 24. It's true. Try another one. Negative 3x equals 27. Negative 3 is being multiplied to x. So do the opposite. Divide by negative 3. Whatever you do to one side, you must also do to the other side. So we're going to divide the other side by negative 3. Use canceling. The negative 3's are going to cancel each other out, leaving the x by itself, and 27 divided by negative 3 is negative 9. Then you can check by plugging negative 9 back into the original equation. Negative 3 times negative 9 is positive 27, so it's true. How about 30 equals negative 0.5a? Negative 0.5 is being multiplied to a, so do the opposite, divide by negative 0.5. Whatever you do to one side, you must do to the other side. Use canceling where you can. Those will cancel, leaving you with just a equals 30 divided by negative 0.5 is negative 60. To check it, you're going to plug negative 60 in for a and multiply by negative 0.5, and you will get 30. It's true. This one is p divided by 4 equals 5. Since 4 is being divided into p, we have to do the opposite, multiply by 4. So we're going to multiply by 4. Whatever we do to one side, we have to do to the other. We're going to multiply by 4 over here. Use canceling. The 4's will cross off, leaving us with just the p, and then 5 times 4 is 20. To check it, we put the 20 back in for p and say 20 divided by 4 is equal to 5, and that is true. All right, negative m divided by 3.5 equals 9.2. 3.5 is being divided into m, so do the opposite, multiply by negative 3.5. To both sides, the negative 3.5s will cross off, because two negatives will make a positive, and we'll have m equaling whatever 9.2 times negative 3.5 is, which is negative 32.2. To check it, we plug that back in for m, and we do 32.2 negative divided by 3.5, and we should get, it's actually a negative 3.5, we get 9.2. Okay, you get to try one, give it a try. Welcome back. Let's write and solve one-step equations with word problems. A scuba diver is exploring at an elevation of negative 12.2 meters. As the diver rises to the surface, she plans to stop and rest briefly at a reef that has an elevation of negative 4.55 meters. Find the vertical distance that the diver will travel. So here is the water level. The diver's under the ground starting at negative 12.2. Water level is 0. She's going to go up to a reef and rest. So there she is, swimming up to the reef. She's now at negative 4.55. Let x equal the total vertical distance from the starting point to the reef. So this is x, from the starting point to the reef. So we're going to make an equation. Negative 12.2 plus x is going to equal where she ends up, negative 4.55. So now we have to solve the equation. We're going to add 12.2 because here we were subtracting it. So we have to do that to the other side as well. That'll give us 0 plus x equals 7.65. The diver went a vertical distance of 7.65 meters. Try one of these problems and I'll see you back. Oh, welcome back. Okay, let's look at this one. Between the hours of 10 p.m. and 6 a.m., the temperature decreases an average of 3/4 of a degree per hour. How many minutes will it take for the temperature to decrease by 5 degrees Fahrenheit? Okay, let's look at the temperature. From the hours of 10 p.m. to 6 a.m., the temperature decreases an average of 3/4 of a degree. So if between 10 and 11, it goes down -3/4. 11 to 12, -3/4, 12 to 1, -3/4, all the way up to 6 a.m. Okay? Let X equal the number of hours it takes for the temperature to decrease a total of 5 degrees. So -3/4 times the X, the number of hours, is equal to -5. I picked -5 because you want it to decrease by 5 degrees. Now you solve it by multiplying by the reciprocal. The dot means multiply. You're multiplying by -4/3. So whatever you do to one side, you have to do to the other, but let's just do this first. So we cross off the 4s and we cross off the 3s and we're left with X. And then we multiply by -4/3 over here. So then X is going to equal 20/3 hours. Change that to a mixed number. Oh, we have to convert the hours to minutes because they asked how many minutes, not hours. So 20/3 times 60 minutes per 1 hour. Those cancel. We're left with 400 minutes, 20 times 20. So it will take 400 minutes for the temperature to decrease 5 degrees. It will take 400 minutes for the temperature to decrease by 5 degrees. Let's try another problem here. Okay, the value of a share of stock decreases in value at a rate of $1.20 per hour during the first 3.5 hours of trade. Write and solve an equation to find the decrease in the value of the share of stock during that time. It's similar to the temperature one. So we have hour 0, hour 1, hour 2, hour 3, hour 3.5. It's a little smaller. So it's going to go down $1.20 every hour. Every hour, -1.20, -1.20. The last half an hour, it's not going to go down a whole $1.20, is it? It's going to go down half of that. So 60 cents, right? -60 cents, half an hour. Half of what $1.20. So let X equal the decrease in the stock after 3.5 hours. So X is the decrease in the stock divided by 3.5 hours is equal to -1.20, the hourly amount of decrease. Multiply by the reciprocal, -3.5/1. Those will cancel out, leaving you just with positive X. Multiply by the same thing on the other side, -3.5. X is going to be left, and it's going to equal, two negatives are going to equal a positive. Well, there's not positive there. So -4.20, it's going to go down by. Write in the solving equation to find the decrease in the value. It's going to go down $4.20. The stock will decrease $4.20 over 3.5 hours. Okay, you get to try a problem like this. See you back in a moment. Oh, this one didn't work out right. Let's see. Which values in the problems below are represented by negative numbers? Well, you got all the answers there. A diver below sea level ascends 25 feet to a reef at -35.5. What was the elevation of the diver before she ascended to the reef? Okay, we don't need to know the answer. We just need to know which ones are negative, right? So which one's negative? The elevation of the diver and the reef, because both are below sea level. A plane descends 1.5 miles to an elevation of 3.7 miles. Descends means goes down. What was the elevation of the plane before its descent? The change in the plane's elevation, because the plane is moving from a higher to a lower level, that's your negative number. So you got to see which ones are the negatives. And nothing is happening to move me on. I wonder if it jammed up. Okay, let's focus on some higher order thinking. In the first case, you divide both. What am I doing here? How do you solve? Wait a minute. Make this a little bigger so you can't see that yet. Okay. How is solving negative 4x equal to negative 4.8 different from solving negative 1/4 x equal to negative 4.8? Well, in the first case, you divide both sides by negative 4 here. In the second case, you multiply both sides by negative 4. So just the opposite, right? Divide by negative 4 here, multiply by negative 4 there. Flynn opens a savings account. In one 3-month period, he makes deposits of this amount, $75.50, $55.25, and then he makes withdrawals, or he takes money out, of $25.15 and $18.65. His balance at the end of the 3-month period is $210.85. How can you find his initial or beginning deposit? Well, you can add the deposit and the withdrawals. Let X represent the amount of the initial deposit. Write and solve an equation. X plus the deposits minus, this should say the word minus the withdrawals equals $210.85. And solve the equations in order. Oops, let me go back a minute. Hold on. Let's go back. So solve the equations in order. So what you do, you solve for A. 3A equals negative 4.2. Find A. When you get A, you plug it in for B, or you plug it in for A, and then you add B equals negative 7.8. So you solve for B. You get the answer for B, and then you're going to plug in 1 2/3 C is equal to A and B, and you know what A is, and you know what B is. And then on the fourth step, this is going to give you C now. You're going to know what A, B, and C are, and you're going to solve for D. Solve this problem on the Your Turn number 5 for 10 points extra credit. Okay, give it a try. It's worth it. Okay, there's your chance. See you back. All right, Google Classroom 6.2. So we are done, and we will say goodbye, and I hope to see you next time. Bye.